Alrighty, let's have a look at some answers here, shall we? A little bit of a review. So, if a wooden block slides down an incline at a constant velocity. Now, in grade 12, we actually spent a fair bit of time dealing with inclined planes. So you'll see more of that picture in your future. If a wooden block slides down an incline at a constant velocity, the force of friction must be equal to the A, force perpendicular to the incline, which I've shown here as A right here. That would actually be the normal force. The force parallel to the incline, that's B. I call that in grade 12, I call it FD for down the plane. It's not really, I'm not giving you a grade 12 question. Just doing a little bit of foreshadowing. Would it be equal to C, the weight of the block, which would be FW, or would it be D, torque force, which is an imaginary thing that I just made up? So it's not that one. So what is the answer? It is indeed B. Correct answer is B. The friction force is opposite to the motion. If there were no friction, which way would it go? Down the ramp. And so friction opposes that motion down the ramp. Now's a good time to pay attention, Ryan. Number 2, an empty wooden crate is slid across a warehouse floor. If the crate were filled, the coefficient of kinetic friction between the crate and the floor would, now this is one that a lot of people get wrong, and is that what happened today? Yes.
Sure was.
And the reason I put this in here is to remind you, once again, that the coefficient of friction does not depend upon the mass, does not depend upon the weight, it depends solely upon the nature of the surfaces. When the coefficient of friction remains the same, this is what it means is, when the coefficient remains the same, mu equals FF over Fn. If I increase the weight, what does that do to the normal force? That's a bad way to write it. Let me write it this way. Right? If I increase the weight, what does that do to the normal force? It increases it. It makes it bigger. But the coefficient remains the same, so for the coefficient to remain the same, what else has to get bigger? The friction force must get bigger. Because the ratio must remain the same.
Why for the friction force though? I get the torque force part. Why?
Because the mu value must remain the same. Let's suppose that the mu value is like 0.4, right? And so if the normal force is 10, what would be the friction force? 4, right? 4 over 10 is 0.4. If the normal force increases to 100, then what does the friction force have to be to remain coefficient of friction of 0.4? It must become 40. Okay, that's why friction increases when you add more weight. It's because the coefficient of friction remains the same. Light bulb on? No, Peyton? An empty wooden crate is slid across a warehouse floor. If the crate were filled, the force of kinetic friction between the crate and the floor would, that correct answer is indeed B, increase. Okay? So I'm going to go through that one more time. Because the coefficient must remain the same, the coefficient of like steel on steel was like 0.7, right? Doesn't matter how much steel, it's 0.7. If you've got more steel, you got more normal force, and if the 0.7 must remain the same, then the friction force must also remain the same. If the coefficient changed, then you couldn't even figure out what the friction would be, right? It's a ratio. It is determined by how smooth the surfaces are compared to each other. Okay, so now, number 4, a 5 Newton block with a surface area A was a B increase, right? Was it B? I don't know. It was increased. Yeah, B increase. Yeah, no, it doesn't depend on whether the Leafs make the playoffs. A 5 Newton block with a surface area A is dragged across a horizontal wooden table and experiences a friction force of 2 newtons. Okay? What would the coefficient of friction be? This isn't up here, but what would the coefficient of friction be if the 2 over 5 or 0.4, right? What is the friction force acting on the 5 Newton block when the surface area is increased to twice the area? Correct answer? I'm hearing the same. B, the same. Does the surface area have anything to do with the friction force? No. Has to do with the pressure. Pressure would be different, but the friction force would remain the same. Which pair of quantities could be used to determine the coefficient of friction for granite on concrete? The mass and speed of the block, the mass and normal force on the block, the frictional force and the speed on the block, the frictional force and the normal force on the block. Which one is it? I believe it is D. It is D. The coefficient of friction is friction force, FF over Fn, right? FF over Fn. That is your mu value. Okay, number 6. I think they're getting a little more challenging. The force required to start an object sliding across a uniform horizontal surface is larger than the force required to keep the object sliding at a constant velocity. This sounds an awful lot like the question about pedaling the bike from about 2 units ago that I keep coming back to. These forces are different because the force of kinetic friction is greater than the force of static friction, decreases as the speed of the object relative to the surface increases as the speed of the object relative to the surface increases, or is less than the force of static friction. Kinetic friction is always, technically it should be, whoopsie, it should be, D should be less than or equal to, right? There should be a less than or equal to, right? Occasionally they are equal, not very often. So it's D. A 50 Newton horizontal force is needed to keep an object weighing 500 newtons moving at a constant velocity of 2 meters per second across a horizontal surface. The magnitude of the frictional force acting on the object is 50 newtons is the applied force. 500 newtons is the weight. The constant velocity is 2. What's the acceleration? 0. How much force is required to keep an object moving, an object in motion? Well, a net force of 0. So how much do I need for a force to make a net force of 0? Should be 50 newtons. Is the correct answer D? It is. 50 newtons. My goodness, these questions seem to be all repeats of previous ones, don't they? A 20 Newton block slides over a horizontal table. If it takes a force of 5 newtons to move the block at a constant velocity, what is the force of kinetic friction on the block? It's the same question, isn't it? Same question. The answer is 5, I think. B. I heard someone say Y. A 20 Newton block, 20 newtons down. If it takes 5 newtons to move if I have to apply a force of 5 newtons, right, and it's moving at a constant velocity, what is the friction force? Minus 5. A 9. Question number 9. A 20 Newton block slides over a horizontal table. If it takes a force of 5 newtons to move the block at a constant velocity, what is the coefficient of kinetic friction on the block? Same. Is that not the same diagram? Same question? I think so, isn't it? Right. So we got 20 newtons. 20 newtons of normal force. We got a 5 Newton applied force and a 5 Newton friction force. Mu equals FF over Fn. Friction force is 5. Normal force 20. 0.25. Oh, is it 0.25 newtons? No, it's just a ratio. It's just 0.25, right? Jake, need to pay attention. We'll wait. Is there only 9 questions? I think there is. Okay. So overall, how did we do? Yeah? View overall results. Okay, so as a group, you guys scored 63%, which is pretty average, really. Plus or minus 2.26 for the standard deviation. You guys know what standard deviation means? You know what marking on the curve means? Do you want me to tell you in about 3 minutes? Yeah? Well, let's just... Okay. Yes, it likely is. This is what's referred to as the normal or bell curve. It's called a bell curve because it looks like a bell. Okay, it's also referred to the normal distribution. When we use the word normal, it doesn't mean normal in the normal sense. Okay, it's just a way to describe this curve. Now, what that means is down the middle, you will find the average. Okay? Marks tend to form what we call a normal distribution, which means when you graph them, you're going to have lots of people near the average, around 62 or so, and you're going to have, this is number of people, right? So you might have like 8 people in a class. Hello, Mr. Jadek. What can I do for you? All right, so back to my little stats lesson here. So in a class of, say, 30 people, okay, let's say 8 people are sort of at average, around 62, right? Well, there's going to be a few people, like maybe 3 people out here at like 80, and there's going to be like 3 people down here at like 40 or so. Okay? So in other words, if I took everyone's mark and graphed them, right, there'd be some people, there'd be a few people around 60, and there'd be some people, less people around 80, and there'll be less people around 40. Okay, that's what we talk about, the curve. Okay, so what does standard deviation mean? Well, if the standard deviation, which we use this funny symbol for, let's say the standard deviation is 10. Okay, just for easy figuring. If the average is 62, then if I add 10 and I get to 72, and I subtract 10 and I get 52, what a standard deviation of 10 means is that 63%, is it 63? I can't remember now. 63% of all the marks should fall between 52 and 72 because the standard deviation is 10. Okay? If you have a really big standard deviation, then that means that those numbers are wider apart. It means the marks are more spread out. If the standard deviation is smaller, it means the marks are more consistent. Your marks are likely very consistent. You always get around 75 or that kind of thing, right? There might be some that are outside that. That's what standard deviation means. It means how spread out the marks are in a class. If they're way spread out all over the place, then what does that mean about the class kind of thing, do you think? Yeah, exactly. Some kids are really getting it and some kids are not really getting it. If the standard deviation is like 2 and all the marks are around 75, what does that mean? It means the entire class gets about 75% of the stuff in the class. Now, marking on the curve. Marking on the curve is the theory that the class should fall in the normal distribution, and if the average is low, right? So what they do is they assign, and it works better with letter grades, they assign A's to the top, say 5% of the people, and B's to the next 15, 20%, and then C's, and then D's, and then, well, F's way down here, right? So marking on the curve means that if the average is really low, and you happen to be quite a bit above average, well, then your mark might actually go up. But that only works when the average is low. If the average is high in the mark on the curve, you might have a high mark and your mark might actually go down. So marking on the curve, people think, oh, that just means everyone gets 10% more. But it's not that. It just means is that they normalize the data. Go ahead, Peyton. The good question, I don't know. Yeah. I don't know. I don't know. I can give you a prime example of marking on the curve, and it worked out beautifully for me. First year university, physics class, the exams were the same for like the last 15 years kind of thing. You'd go to the library, you'd get a copy of an old exam, and then you'd look at it, and then your next exam would be like, not identical, but there was like 300 questions that they picked from, and then they just sort of randomly showed up on the exams, right? So it was pretty easy to study for. the professor that used to make the exams died right before final exams. It's too bad, right? Yes. I never met the man. I don't know who he is. So someone new decided to make up an exam with entirely new questions. Ooh. Excuse me, Jake. I don't need language like that. So what happened to the kids that really just studied by memorizing answers and stuff? Down. What happened to smart people like me that understood the physics and could apply it to new and novel situations? Because the average went down and I was considerably above average, my mark went from a B to an A. Yay for me. That's what marking on the curve means. Pardon me? I don't know if they do anymore. Yeah. I don't know if they do. If you're going to be marked on the curve, what you want to do is you want to get yourself into a class with people that aren't very smart because you want to be above average. Well, yeah, there would be, yeah. No, it's the idea that the curve, that the marks should be normally distributed. And if the average is low, it just means that the test was really hard, right? And if you got above average on a hard test, well, then you deserve a B. That's the thinking behind it. So that's what standardization, standard deviation, and marking on the curve means. It's just how good you did in relationship to everyone else. Exactly.
So like if I got like a 99, but like everybody else got a 98, I would get like what?
See? They don't really do this anymore. But that's what marking on the curve really means, you guys. Yeah. That's why they stopped doing it. Okay, I'll stop talking. You've got some more questions you can work on.